Today's notes are identifying parallel and perpendicular lines. We say that two lines that do not intersect on a graph are called parallel lines. Mathematically, lines are parallel if and only if they have the same slope and different y-intercept. So let me go ahead and jump in and go ahead and start writing this down. They need to have the same slope and different y-intercepts. If two lines are vertical, then they are parallel if and only if they have x-intercepts. So the easy way to think of this is like, well, I mean, obviously, if the lines don't touch, they're going to be parallel, right? But basically, in order for them not to touch, they need to be growing or decaying at the same rate. So we're going to say that the lines, the slopes need to be parallel. Obviously, they need to start at a different spot, or else they're just going to end up being the same line. So it says graph a parallel line to each one of the loads that satisfy the requirements. So first of all, I want you to notice that for this one, I need to find the slope first, okay? So I'm going to take a look, and I see from this dot to this dot, it looks like this thing went up 3 and right 1. So we're going to say that the slope is 3 over 1, which is 3. So I need this to have a y-intercept of 5, and it needs to have a slope of 3. Let me go ahead and write the old equation. Well, the old equation was y equal to, for the old equation, it has a slope of 3 and a y-intercept of 2. For the new equation, I needed to have a slope of 3 and a y-intercept of 5. So from 5, I'm going to start here, and I'm going to go up 3, right 1, put a dot. I'm stuck going that way, so I'm going to go in the opposite direction. I'm going to go down 3, left 1, put a dot. Down 3, left 1, put a dot. And if you do this correctly, then your line should look like this. I want you to notice that those two lines are running right next to each other, but they're never going to cross each other up, okay? Because they're parallel, right? We made it so that they're parallel, so in that they were able to have the exact same slope, but they started at a different spot. Forgot to highlight this. Let me go ahead and write parallel lines need to have the same slope and different y-intercept. All right, I want to do the same thing with this one. This time I want a y-intercept of 7, and I want it to be parallel to this. So let me just see what's happening here. This one, it looks like from this dot to this dot that's crossing at the corners, it went up 1, right 1. So I'm going to say that the slope is 1 over 1, which is 1. And that means the equation for this line was 1x, but I don't write 1x. I'm just going to write x. And it started at 4, so y equals x plus 4. That was the old line. The new line, I needed to do the same thing, but I needed to start at 7. So I needed to have a y-intercept of 7 and a slope of 1. So I'm going to start at 7, and a slope of 1 means go up 1, right 1, put a dot, up 1, right 1, put a dot. Same thing in the opposite direction. I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, and I'm going to put these dots going straight across. If you connect these, I want you to notice that your line is never going to touch the other line, right? They're running parallel to each other, which is exactly what I wanted. So the equation of this line is going to be y equal to x plus 7. Then for the last one, I want to have it parallel, but I wanted to have an x-intercept of -1. So let's see what's going on here. This thing is going down to right 1. So your slope is going to be -2 over 1, which is just -2. For my old equation, it's y equal to -2x is the slope, and it started on the y-axis at 3. In order for me to go ahead and do the new one, I need this to have a y-intercept of -1. I'm sorry, an x-intercept of -1. Ooh, that was a little scary. And then a slope of -2. So the x-intercept of -1 means I need the dot to be right here. And from here, I need to go down to right 1, put a dot. Down to right 1, put a dot. Except that's not going to work, so I'm going to go the opposite direction. So I'm going to go up 2, left 1, put a dot, up 2, left 1, put a dot, up 2, left 1, put a dot, all the way through. And if you connect these lines, they should be running parallel to each other. And my new equation is going to be y equal to negative 2x. I want you to notice that my y-intercept is a positive 2. All right, what do we notice about the slopes? Well, take a look at the slopes on this one. It looks like this had a slope of 3, this had a slope of 3, this had a slope of 1, this had a slope of 1, this had a slope of negative 2, this had a slope of negative 2. So we're going to say that the slopes are the same. What about the y-intercepts? Well, the y-intercepts are different. And that's how you create parallel lines, is you got to make sure that the slopes are the same, but that they are starting in a different spot. Okay. All right, let's go ahead and take a look at the next one. Our next definition for today is two lines that intersect at 90 degrees are called perpendicular lines. So if they're going to cross each other up perfectly at a 90-degree angle, we call them perpendicular. Mathematically, lines are perpendicular if and only if their slopes are opposite reciprocals of each other. When I say opposite, I mean they're going to have the opposite sign. So if the first one's positive, the second one's negative. And as far as reciprocals, then we need to flip the fraction as well. So not only do you need to change the sign, but you need to flip the fraction. So I want to graph a perpendicular line to each one of these below that satisfies the following requirements. I want this first one to be perpendicular and have a y-intercept of positive 3. So first, let's see what's happening each time. In this case, it looks like it's going down to right 1. So I'm going to say that my slope is negative 2 over 1. So my old slope is going to be negative, which by the way is negative 2, right? But my new slope, because I want it to be perpendicular, I need to change the negative into a positive. And I need to flip that 2 over 1 and change it to 1 over 2. So the slope changed from a negative 2 to a positive 1 over 2. Now the only thing I need is for me to have a y-intercept of 3. So here's my y-intercept of 3. From here, I'm going to go up 1, right 2, put a dot. Up 1, right 2, put a dot. Up 1, right 2, put a dot. I'm going to go in the opposite direction. I'm going to go down 1, left 2, put a dot. Down 1, left 2, put a dot. Down 1, left 2, put a dot. I'm going to go ahead and connect these dots. And look how this equation goes. Not only do they cross each other up, but they cross each other up in a 90-degree angle. So be careful when you're doing these. It's not just saying like, oh, two lines are touched, then they're perpendicular. No, not only do they have to be crossing each other, but they have to cross each other with opposite reciprocal slopes. Okay, it has to be exactly an opposite reciprocal. All right, let's try the next one. I want to create a line that's perpendicular to this line, and it passes through 2, 3. Let's see. First, I need to figure out what's going on with this line. So it looks like this one's going up to right 1. Up to right 1. So my slope up to right 1, which is the same thing as a positive 2. This time, if I want to flip the positive 2, I'm going to change this. It was positive, now it's negative. It was 2, well, you can't flip 2, so that's going to be 2 over 1. I'm going to flip it to 1 over 2. And I want it to pass through the point 2, 3. Here's 2, 3. I want my perpendicular line to pass through this point. So this is going to go down 1, right 2, put a dot, down 1, right 2, put a dot. I'm going to try the exact same thing going in the opposite direction. I'm going to go up 1, left 2, put a dot, up 1, left 2, put a dot, up 1, left 2, put a dot. We're going to go ahead and connect these points. Again, not only are these lines crossing each other up, but they're doing so in a 90-degree fashion. So I can put a little box right here. say this makes a 90-degree angle. All right, last one. I want to construct the perpendicular line to this one, but this time I wanted to go through -2. Guys, one of the things I noticed as I was doing this, I didn't mean for this. I want to cross these numbers out. I don't want them to be counting by twos. I want them to be counting by ones, and that was a mistake on my part. I didn't notice until it was way too late. So it's just going to be 1, 2, 3, 4, 5, 6. Okay, so let's see. I'm going to go ahead and start at a y-intercept of -2. Oop, first I got to figure out what's going on. This thing is going up 2, right 1. So my slope is 2 over 1, which is just 2. I already know what's going to happen here. That's going to be a 1 over 2, but this time I want my y-intercept to be -2. So remember, we're going to count normally. Let's see. So this is -1, -2. And then from here, I'm just going to go down 1, right 2, down 1, right 2, put a dot, and doing the exact same thing in the opposite direction. And we're going to go ahead and connect these dots. And this makes them 90 degrees. Okay, so that takes care of the first page of notes. We're going to go ahead and jump into the backside. On the backside, it says, determine if the graphs are parallel, perpendicular, or neither. Write a brief description as to why. Remember that parallel lines are going to have the same slopes. They're just going to start at different spots. Perpendicular lines are going to have opposite reciprocal slopes. And if our slopes are doing anything other than that, then, it's going to be neither, because it's not parallel or perpendicular. So don't just go, oh, it looks perpendicular. Like, that's not good enough, guys. You need to really understand what's happening with those slopes. Okay, so let's see what's happening on my first line. Let's take a look at that purple line first. I'm going to start from here, and it looks like the next dot is going to be here. So what happened on this graph? In this graph, it looks like it went up 3, right 2. So the slope for the first line, I'm going to call this M1, equals 3 over 2. The slope for the second line, well, let's see, how did I get from this dot to this dot? Well, in this case, this slope went down 1, right 2. So my second slope is -1 over 2. So let's see. First of all, they're definitely not parallel. I mean, I could have told you that from the very beginning, just because, like they're crossing each other up. So they're not parallel. So maybe they're perpendicular, but if they're going to be perpendicular, I need the opposite reciprocal slope. So let's see. The opposite of a positive is a negative. That works. The opposite of the reciprocal of 3 over 2 is 2 over 3, and that's not what I have over here. So even though it looks like they're perpendicular, they actually are not. So I'm going to go ahead and say that these slopes are not equal and are not opposite reciprocals. So neither. Yeah, these aren't parallel and they're not perpendicular. Okay. All right, let's take a look at the next one. I'm going to go ahead and try to find good dots. It looks like I can go from here to here. Actually, you know what? Let's do this. Let's start with the second one first, just because I want to show you something. So let's go ahead and go from here to here, okay? This one went up to right 1. So the slope of the second line is 2 over 1, which we know is just 2. And let me show you on this one, we're going to do something kind of weird. We're actually not going to go from this dot to this dot. We're going to go from this dot to this dot, just so I can show you, like, it doesn't matter. As long as you guys are picking good dots, we call them lattice points, these should work out anyways, because I know you're looking at these and going, whoa, those triangles are way different. And that's okay. In this case, I went up 4, right 2. So my slope for the first line is 4 over 2, but I know 4 divided by 2 is just 2. Check that out. It didn't matter that I actually skipped over one of my dots. As long as you simplify, I could have done this, right? And it would have been 2 over 1. As long as you simplify, you're going to get the same answer. So what do we notice? We notice that they have the same slopes. Obviously, they start in a different spot, so they are parallel. Okay, let's take a look at the next one. I'm going to start from this dot and go up to right 1 to get to the next dot. So my first slope is up to right 1. That's going to be 2 over 1, which is just 2. My slope for the next one is going to be down 1, right 2. Remember, it's rise over run. So down 1, run 2. Well, my first slope was 2 over 1, positive. The second one's negative, so that's opposite. And if I flip the 2 over 1, it becomes 1 over 2. These are opposite reciprocals. I'm going to say slopes are opposite reciprocals. So lines are perpendicular. And then let's take a look at these last two questions, or those last two lines. Notice that the lines are not touching each other, so they might be parallel. But let's just take a look at the slope and see what's going on. This one's going down 1, right 3. So my first slope is negative 1 over 3. And my second slope, to go from this dot to this dot, down 1, right 2. These are different slopes. And not opposite reciprocals. So it's not parallel and it's not perpendicular, so neither. Okay, so hopefully you got a good idea of when lines are parallel and when they are perpendicular. We can also identify parallel and perpendicular lines without a graph. We can do it just by looking at the equation. Remember that parallel lines have the same slope and different y-intercepts, while perpendicular lines have slopes that are opposite reciprocals. You know what? I'm just going to highlight that because, man, this is really what we need to get. Parallel lines, same slope with different y-intercepts. Perpendicular lines have slopes that are opposite reciprocals. So if we can get that through, we should be okay. All right. Use the equation y equal to 2x plus 5 to determine if the following equations are parallel, perpendicular, or neither. I'm going to go everything off of that 2x plus 5. All right, so let's see. I know my slope here is 2. And you know what? Let me go ahead and kind of separate these because we're going to need some space. I mean, a good chunk of this is just, can you figure out the slopes and the relationship between the two things? So the first thing I noticed that the slope, so if my first slope is 2, this second slope is negative 1 over 2, which is the opposite reciprocal. So slopes are opposite reciprocals. So perpendicular. This must mean that these two lines are perpendicular to each other. Let's take a look at the next one. Unfortunately, I can't really do that as quickly on this second one because it's not in slope intercept form. So on the first one, I knew exactly where the slope is. On the second one, I don't know exactly where the slope is. So what I'm going to do first is I'm going to put this into slope intercept form. Then I can tell you, oh, the slope is this. Then I know what the answer is going to be. So let's go ahead and start manipulating this. I'm going to subtract 6x from both sides. And again, I'm just trying to get it to look like y equals mx plus b. I get 3y equals negative 6x plus 12. I'm going to divide everything by 3. These are going to cancel. I get y equals negative 6 divided by 3 is negative 2x plus, and then 12 divided by 3 becomes 4. So my slope is -2. Are the slopes the same? Nope. Slopes are not the same. Are they opposite reciprocals? Well, they're opposite, right? Because the first one's 2, the other one's a -2, but there's no reciprocating going on. There is no flipping. So the slopes are not the same and are not opposite reciprocals. So this is going to be neither. All right, let's try this one. I got y minus 4 equals 2x plus 9. Now, hopefully you can recognize right away that the slope is going to be 2. But some of us are not so good, especially me. I'm not really good at recognizing that that's point slope. I would actually put it in y equals mx plus b. So we're going to go ahead and do that just in case you didn't see it. I'm going to go ahead and distribute this. This gives me y minus 4 is equal to 2x plus 18. And then I'm going to add 4 to both sides. Y equals 2x plus 22. So if you notice, the slope is still 2. If you didn't catch, like, oh no, that's just point slope form. I know the slope is 2. The slope is still going to be 2. And since my slope is 2, that actually matches up with my other slope of 2. So we're going to say same slopes. They definitely have a different y-intercept because of the 5 and the 22. So these lines are parallel. Okay, and we're going to go down to our last one. Let's see what we have here. I have 2y minus x equals 14. Let's go ahead and get rid of that x by moving it to the other side. Remember, I want it in y equals mx plus b. 2y is equal to x plus 14. Divide everything by 2. I got y equals, now in front of that x, remember there's an imaginary 1. So instead of saying 1x, you know what, I'll write it out the long way. 1x over 2 plus 7, which really this becomes y equals 1/2 x plus 7. So let's take a look at our slopes. The first slope is 2. The second slope is 1/2. Are they the same slope? Obviously not. Are they opposite reciprocals? Well, they are reciprocals because if you flip the 2, it becomes a 1 over 2, but they're not opposite reciprocals because the first one was a positive, second one is the negative. So we're going to say different slopes and not opposite reciprocals. So neither. Okay, that takes care of the notes for today. Hopefully that made sense. If you have any questions, as always, feel free to ask.